Okay. Absolutely. So, this is a talk on Ansible and why it works for me. If you didn't already know my name, it's up on the screen. This is probably going to be shorter than 45 minutes now, but it's an overview of Ansible. It's meant to be a 101. You're not going to learn everything there is to learn about Ansible from this talk, but hopefully, if you have any interest in it, when you walk away tonight, you'll be able to go, give it a shot, see what you think of it, and possibly make use of it in your work or home lab. This is stuff about me that's unimportant, but I work at Binary Defense Systems as a security developer. I am not help desk, just pointing that out. And 10 years, did some VoIP stuff. That's about it. Blazing through it. It's a little bit hard to read up there, but the bottommost portion is where these slides are. So if you miss anything, or if you really wanted to read that bio, don't know why, you can find it on my GitHub. Also, Twitter, if you want to join my buddy and make fun of me, there's my handle. There you go. On to the show. So, because we are vendor neutral here at NEOISF, I want to make sure I present some alternatives. Those include Chef, Puppet, Salt, and a whole mess of others, but I cherry-picked those ones because they make really good examples. They do a really good job of contrasting what I love about Ansible versus what I can't stand about those alternatives. There's actually a lot of differences. I'm going to cover a few because I don't want to hit you guys with a wall of text. But for now, let's cover what is Ansible. Funky name, right? What is it? What is it going to do? Well, if you read their website and the marketing speak at the top, it's DevOps made simple. Deploy apps, manage systems, crush complexity. Ansible is a powerful automation tool that you can learn quickly. And of course, that's why I picked it for a talk. If you look on Wikipedia, because it's always interesting to see their take on it, whether it's fact or fiction, Ansible is a free software platform for configuring and managing computers. It combines multi-node software deployment, ad hoc task execution, and configuration management. Sounds kind of complicated. It's not. Don't worry. Another definition of Ansible, a way to maintain sanity in the complex and ever-changing world of system configuration. That one's me. Kind of a fanboy for it now. It's pretty awesome. And hopefully you guys will think so after I get done with this talk. But Ansible, that's a really odd name. What is it? Where did it come from? Did they just make up some word? Well, it's actually named after a fictional instantaneous hyperspace communication system featured in Ender's Game, which you guys have probably heard of. And just kind of an interesting fact, releases are named after Van Halen songs. Why not? So, in order to run Ansible, what do you need? Well, because this is talking about multiple machines, you're going to need a server, you're going to need a client. Let's go over what the server is. And the server in this instance is a control machine. It's the place you're going to control or configure your other machines from. Doesn't have a lot of requirements. Linux or Mac currently. Sorry, Windows guys. You need SSH, Python 2.6 or later, and if you're running something earlier than Python 2.6, may God have mercy on your soul. How about the client? Managed node in Ansible speak. Well, those can be Windows. They can also be Linux or Mac. If you're doing Linux or Mac, then it works over SSH. If you're using it to control or configure Windows machines, it works over PowerShell, which I think is pretty neat. And this needs Python 2.4 or later, same as above. Don't run Python 2.4 unless you have to. And that's it. This is one of my favorite things about Ansible. There's not a lot of setup. You don't need complicated dependency chains. You don't have to install all kinds of third-party modules and pieces parts. You only need this. And that makes it very easy to hit the ground running. I mentioned at the top about a home lab. If you're trying to configure, to manage a home lab, you can do it by hand, individually. That's fine. Or you could do it through Ansible. The benefit of that being that now you have something that you can always reset. It's one of the things we love about virtual machines, right? Something goes wrong, especially on a lab machine, reset. Ansible will give you that functionality. So let's learn some of the lingo. What this Ansible thing, we're all talking about a node. It can be really complicated to get into a piece of software and understand what it's going to do for you if you're just hitting this wall of text and going, what does that word mean? Does it mean what I think it means? Really good spot to insert a "that's not what you think it means" slide. Inventory. Inventory in Ansible is simply a list of the machines that you wish to configure or control. That's all it is. Playbooks. Borrowing from some sports ball here. Playbooks are what you are going to want to do with those machines. And we can talk a little bit later about how you can break up playbooks into different pieces. Software guys, we love reusability. But for now, just accept it as something that contains the plays, the things that are going to happen on the machines that you've got in your inventory. The next are grouped together because they're all kind of intermingled, but we'll go down them one by one. First one is roles. This is one of the ways that you segment your playbooks. And so most likely, if you're working with something like a home lab, you've got maybe some web servers, you've got maybe some Windows boxes that are there just for clients, Windows XP, that sort of thing. You don't want them both to have Apache installed, or Nginx, or insert your web server of choice. You want your web server to have it, and you want your client machines to have something completely different. That's what roles provides for you. Each of the roles and each of the plays in the playbook are split up into tasks. This one's pretty accessible. It's not that out there. It's literally just a task. It's something like you would put on a to-do list. What do you want to do with it? So maybe with Apache, you're going to want to install it. Maybe you have some configuration you'd like to do. Default log settings, not for me. Definitely need to change those. Individual items like that are tasks. The next one down is handlers. Handlers are part of what you build your tasks out of. We're not going to spend a lot of time on this one because it's easier to show you what they are and how they're used rather than to cover it right now. And variables. Say in that same lab you have 2 web servers. You don't want them to have the same IP addresses. You might not want them to have even close to the same configuration. If you're using the same roles and the same tasks on them, that would happen without variables. But same thing, it's very accessible. It's exactly what you think it is if you've had any experience with variables in the past. The last one is modules. And this is where the real power lies with tasks. Tasks leverage modules in order to get work done. What does that mean? Tasks use little programs, you could think of them, in the module to get something done. Maybe it's something as simple as print out a message on the screen. You use a module to print that message. And we'll see an example of this later on. Bonus lingo. Galaxy. This is a fun one. The Ansible Galaxy is just a collection online. And one of the benefits of this is the fact that you can go online and look through the Galaxy to learn, to see what other people are doing, how they've made their own playbooks. Allows you to possibly use that as a launching point, especially if it's something like a home lab. You don't have a lot of time to devote to it. You're not going to want to have to write all of the same thing that someone else has already done. So this can be very beneficial. The other one is Tower. Something we haven't mentioned yet, Ansible, this awesome thing, free. They have a wonderful business model, right? And for only $24.90, never mind, different talk. Tower is their business model. So far, everything you're going to be doing is done in files, text files, configuration files, and at the command line. If you're going to be using this in a production environment for a workplace, that's probably not going to pass the muster for most people. They want to see some pretty graphs. Let's have something to show that our servers have been up for 3 years straight. Tower. Tower's the answer. And there are alternatives, but this is how they make their money. And I think it makes a lot of sense. Give us all the tools we need, sell the shiny interface for the other people. Don't know who those other people are. Other details that I haven't covered so far. Ansible is agentless, another amazing feature. When you spin up a machine in order to configure it or control it with Ansible, you install the dependencies I mentioned. Got to have SSH, got to have Python. That's all. There's no Ansible piece of software that goes on the machine. It's just using SSH and Python to get done what it needs to. This also means that you don't have to worry about versions getting out of sync. What if my client and server have different versions of Ansible? That doesn't happen. There's no agent. You just grab it and go. All of the configuration that we've mentioned, the tasks, the roles, all of this is done in YAML files. I won't be covering that here. It's very well documented. But basically, it's very accessible, very easy to read files that are configuration for what you want to do with the machine. And I'll have some examples in the demo for that. Ansible is also extendable. If you really want to dive down deep, or if you get into a situation where at your workplace you need a specific module that hasn't been written yet, you can write your own. They're Python. It's not too hard to do, and you can get done what you need to and move on. Also, Ansible is primarily push-based. There is an option for pull. It's always good to have options. But most of the time, because it's agentless, you're just going to be pushing to another machine. I also like this idea because I kind of can manage where my important files, maybe my passwords, any configuration information, I can manage where that's at and where it's going. I don't have to worry that behind my back something is pulling information to other boxes that maybe I just needed to do one or two things on. More details about Ansible. It communicates via JSON protocol. It uses a very complicated word, idempotent configuration, but all that really means is that it's going to be the same every time you run it. If you have a box that you're resetting up, it'll be the same. It's a mathematics thing, complicated word. What matters, your box will have the same configuration every time you run it. And I'll show you an example of that. Also, if you do want to use this in the workplace or in a production environment, they do have cloud integration. Rackspace, OpenStack, DigitalOcean, CloudStack, Eucalyptus Cloud, AWS, VMware, and KVM, it supports them all. And so it's very easy to pick where you want to use it. So let's put this all together and do a quick demo. Okay, I was going to do this side by side, but the resolution is low enough that we're going to have to bounce back and forth a little bit. So we'll start here in this script. You don't have to use this script. This is just for illustrative purposes, but you will be using this command, and that's Ansible Playbook. Ansible Playbook is what you're going to be doing most of your work with. In this case, we're specifying a playbook file. We're specifying an inventory file. We're limiting where we're running this, and we've got a couple other flags that I'll explain better in a moment. So in order to see this in action, let's go ahead and start it running. So this is that same command. You can run it via the command line, but I'm running it as a script just to illustrate. Yeah. Okay, and I will cover this in a moment, but it's asking for the SSH password. You can use keys. You don't need to use a password. You don't need to type it in every single time. You can automate this. You can use key-based verification on the SSH client, in this case, talking to the server. However, I'm using an SSH password just so that I don't have to cover all of the keys and how that works and why I got there. I'm talking to two virtual machines that are essentially Debian, latest version, Jessie, that has SSH installed and Python, which is pretty much how it comes out of the box. That's it. No keys, no extra files. They literally only have that set up on them. So we're going to go ahead and kick this off. It's going to have a wall of text. And in the meantime, and break. Awesome. In the meantime, we're going to go back to the files. So this is the command that got run. We'll start with the inventory file, if only because it's the next tab over. It's really simple. And all that really matters is the text that is the most to the left. So the test hosts and the two host names. Now in this case, I've assigned some IP addresses. That way I can rotate them because they are virtual machines. They have different IP addresses every time. But all that you would need in a stable environment are these host names. If it can look it up, then it'll use that, look it up, do what you requested of it. If it can't, there are helper variables that you can set, such as the IP address of the machine you're talking to. Going back to the command, the next file we'll look at is the playbook. So we've covered the inventory of what machines we're working on. Let's take a look at what we're trying to do to them. I do have to crank down the font a little bit on this. However, we'll just kind of hit the highlights. And again, if you guys want to see these slides or this demo, it is included on GitHub. So you can go take a look, tinker around with it, see what you think of it. First and foremost, we've got hosts. In this case, we're saying all hosts. Run this play on all of the hosts. Now, back in the command, we're limiting this just to the test hosts, which are this group that's in the inventory file. But the playbook itself will look at whatever hosts you've told it you can see, you can look at, you can touch, you can configure. In this case, all. Fairly straightforward. The next thing is the list of tasks. We've got set the host name. Who doesn't love setting the host name? There's an XKCD comic for this. We've got updating the etc hostname file, and we're using a template for that, setting some permissions, making sure that it's owned by who we believe it should be owned by, and even specifying a condition for it. And I'll review that in a moment. We're also going to update the etc hosts file, same idea, roughly the same thing. And then let's get down to something a little bit more useful that takes a little bit more work. I'm going to install my favorite set of tools. I love HTOP. It includes strace and ltrace as some dependencies, and nload. If you haven't checked these out, they're fun. I'm telling you, riot, party time. He likes them. So, this is using the apt module. It's using a list of items, htop, strace, ltrace, nload. It's going to be running as sudo. Yes, you can sudo tasks. They can run with sudo credentials, which is why it prompted me for that password. And it's just going to make sure that all of them are present. State equals present. If they're already there, it's not going to do anything. They're already present. If they're not there, it will install them. And while it's doing that, it will make sure to update apps cache. Now, if you're not familiar with Debian, basically what this is doing is installing these 4 packages if they need to be installed. And that's that piece that I told you about. The configuration will be the same every time. If they're already installed, they will stay installed. Nothing will happen. If they're not installed, they will be installed. If only half of them are installed, the other half will be installed. That's one of the beauties of the way that this has been set up. Going back up a little bit, we'll take a look at this when statement. When Ansible OS family equals Debian. All this is doing is making sure that this task runs on Debian. Now, why would we need to do that? You can have the same task with different versions to run on different platforms. This is a variable. This is the Ansible OS family, something that's provided to us, but still a variable that gets set. So if I have CentOS or Red Hat, I can create tasks that will only run on those instances. That means I don't have to segregate it out and have a million different files, make sure that I'm running the right one. Ansible will take care of that for you if you plan your tasks accordingly. I also have some tags on here. Those aren't covered in this talk, unfortunately, but it gives you some homework to do if this interests you. Looking at this task, the module it uses is template. Anybody guess what template does? Okay, I'll tell you. Template takes a template, puts in the values that you have configured in the form of variables, and then saves that template to where you tell it to. So we're using a template from the templates directory. We are saving it. The destination is etc hosts. And the template module allows us to set the owner and the group and the mode. There's actually an amazingly well-documented set of modules that are the core set of modules for Ansible. I say amazingly well-documented. I don't use that lightly. I am very impressed with their documentation. So learning this on your own is not nearly as painful as it could be.
Now, when it says source, is it referring to the actual server pushing up to the client, or is the source actually on the client itself?
The source is referring, so the question was, is the source referring to the server or the client, to where we're running Ansible, or to where Ansible is reaching out and configuring? And the answer is, it is on the server. And that's one of the benefits. You can keep all of your templates on the server. You don't have to figure out how to get those files to the clients. It takes care of it. Any other questions while I'm pausing? Cool. So going back to the example that failed spectacularly because this is a demo, you'll notice there's different sections here. We've got play, gathering facts, task, task, task. This is how Ansible communicates back to you what's happening. It runs in parallel. It talks to the hosts at the same time. If I had 50 hosts on here, it would be talking to 50 hosts. In this case, I only have 2. Host B, host A. You'll notice that they are not in the same order in every section. That's because it's talking to them at the same time, so whoever responds back first is put first in the list. However, it first gathers facts. So, for instance, the Ansible OS family. It gathered that fact. Then it's going to set about doing its work. In this case, it's got a task. It's going to set the host name. This should look very familiar. Task, name, set the host name at the top. Kind of bled out by the light. I promise it's there. It then goes on to do the other tasks that we've indicated. And you'll notice some of these are changed and some of these say okay. Changed means something was changed. Okay means that it did not need to do any work. And you'll notice at the bottom that it has failed one of the tasks. Now this isn't a problem. I can run the same set of tasks over and over again because it's going to end up giving me the configuration that I've specified in the file with the tasks. It's going to end up with what I want no matter how many times I run it. And at the bottom, It gives us a list of the hosts, whether they had any okay items. Yes, we did. Some changed items. Or maybe some of the hosts were unreachable. That's there too. Lastly, that you can't tell at the far right, that text is in red on this screen. It says failed, and you'll notice we did have a task that failed on both of the machines, and it dutifully reported it to us. Any questions on that?
The task fails to go to the next task, or does it just stop when you're out?
Depends on how you've written your file.
So it says to retry. If you use that label.retry, is it just going to try the failed tasks?
Yes. It will try the failed tasks on the machines that they failed on. So if I had some machines that completed successfully, those won't be touched. The failed ones will. And all that playbook.retry is a modified inventory file that contains only the hosts that failed. So it's very accessible.
A question for you. Is it multi-threaded, so we'll update two hosts at the same time, or is it kind of chained down in this one host?
It's multi-threaded.
Okay.
Multi-threaded in that it does them in parallel. Any other questions on the demo? Awesome. I've got a few tips, tricks, pitfalls that I've run into while working with this. I'm going to go through them real quick. Yeah, demo fail. How to iterate over a list from a shell command. This doesn't sound that useful, but it is. If you have a command on the machine, this one's kind of specific to a Linux machine, notice the slashes, you can take the output of that command in the form of lines and register it as a variable to use later on. However, I ran into some trouble with this. I had to look up the documentation a few times. When you do that, the output will actually have a variable underneath it, you can think of it that way, called standard out lines. And that's what you want to work with. If you just try and work with output, you're going to have a bad time. One of the things that you can do, it's kind of a tip or a trick, you can store host-specific variables in a host_vars folder. This is a separate folder. You can just kind of manage independently your different hosts and what you want to see for them. Conversely to the tasks, one huge file for a given role, you can separate out the different information, the variables that you want to treat, the IP addresses, the host names in my example, into separate files, which also makes management very easy, especially if you're using something like source control. To only run a task when a list is not empty, for instance, that list of lines that we got from a command, you can use this. Again, these slides are up on GitHub. Feel free to take a look at them and use these examples whenever you can, because they have been amazingly helpful to me. When list, pipe character, length greater than 0. This is really hard to Google. That's why it's in here. If your task hangs forever and you used sudo to run it, confirm that you passed this flag. Whoop. This flag, last one on the list. If you don't have this, then it won't be able to sudo, and it might be having trouble running the command. It's very, very conservative about the fact that it won't run the command if it can't, but there's some problems you can run into where it'll just kind of get stuck, and you won't know quite why. I haven't found an official bug for this, but if I ever do, I'll make sure to put it in with the slides. However, at the moment, if you're running tasks with sudo, just make sure you specify this, and it will ask you for the password. There are two ways to structure our variables. We were talking about variables and how they can be different for different hosts. You can either do them as dictionaries, and this is YAML stuff, Python stuff. So dictionary is a special word, but in this instance, all you need to know is a variable that's broken up by dots. networking.interface.ip. You can create whole trees of these, kind of like the file system, and they're awesome. However, there's a gotcha. The way that Ansible handles dictionaries, when you set a value somewhere in that tree, it sets the whole thing. And so many of the examples that you'll find in Galaxy and elsewhere use underscores to separate the different pieces. This doesn't give us a pretty tree. However, it does mean that if we set that variable, it's only going to be setting that variable. How are we doing? So, back to those alternatives. Chef. There are some differences between Ansible and Chef. Chef is written in Ruby and Erlang. It uses an agent by default, which is one of the things that I really like about Ansible. It doesn't. You can only use it free up to 25 nodes. Ansible, free. If you want the pretty GUI, tower, pay money. Chef, go past 25 nodes, either intentionally or accidentally, and you're going to be paying them money. Also, it's split between hosted and on-premise versions. Similarities. The primary similarity between these, the kind of table stakes for all of them, is cloud support. So Chef does have cloud support. Puppet. Puppet's another popular one, and it's kind of fun to say. The differences between Puppet and Ansible are Puppet is written in Ruby. Ansible is written in Python. It requires an agent. There's that sneaky agent. Again, another piece that you have to install. Make sure it's up to date. Don't get it to be a different version than your server. You'll run into bad times. Really annoying. I love Ansible. It's split between enterprise and open source. There's an open source version. Awesome. But it's not their enterprise version. If you want their enterprise version, you have to pay money. Ansible, it's just there. It's open. Go ahead, use it. Don't have to pay any money. Enterprise tier is a paid tier, like I mentioned. It's largely GUI driven, which for the right kind of person can be beneficial, but I like my command line and my text files and the GUI if I really need it. Also, it does have cloud support. Salt and Salt Stack. Salt is often referred to by either of these names. The differences are that I'm detailing here at least, that I could easily access, is the fact that it uses 0MQ instead of SSH. Again, I prefer Ansible because SSH is a known quantity. I know SSH, I understand it. 0MQ is a programming library. And I'd rather separate those things, keep the concerns different so that I'm using SSH to remotely get into my boxes, not some back end that I can't manage and control. However, Salt and Salt Stack is also written in Python. The end. Any questions before I run away?
It uses SSH for the Linux, obviously, but how does it do it on Linux?
PowerShell. PowerShell through its remote